just use that all year. So there is graph paper in the back. If you just kind of flip in the back, you'll see them right here. There's a bunch of them. Okay, there's like 10 pages worth. All right, so we're going to look at this. This is practice 131. Just to remind you, practice is the title of the section we're always looking for. Since my page numbers don't match, you can look at the bottom for the section you're in. And then the practice is always going to be the last page. So if we turn the page, we see that, there's a blank notes page, and then it goes to the next section. Okay, so the practice, every time that I'm asking you to do the workbook or the textbook, it's always in practice. Okay, so just look for that. You'll get used to it. If you still can't find it, email me. All right, let's see. We're looking at number 3. All right, so first, use the given information to write equation, then graph. All right, so we're going to do the same step before. Remember, all these are linear equations, so I know that I'm going to end up using my slope-intercept form. Here's my slope, right? Here's my y-intercept. Now, we also know something else about these things. This right here is going to be our constant. And within the context of word problems, this is, well, let's put the title here. This is number 3, workbook. All right, so the constant is always going to be kind of like the base rate. So if you go on a taxi ride and it costs $5 just to use the taxi and then $1 a mile, the $5 just to use the taxi is going to be the constant. That's what you're going to pay no matter what. Then you're going to have some cost per mile you go or something like that. Okay. So the key with this is always identifying what is your B value. Once you know your B value, the rest is going to fall in place. But we're going to approach this in how we did with writing an equation. So first we're going to read it and then put our parts in here. Okay, a gear on the machine turns at a rate of 2 revolutions per second. Let X represent the time in seconds. Let Y represent the number of revolutions. What is the equation that models the number of revolutions over time? Okay, so let's see what we have. A gear on a machine turns at a rate of 2 revolutions per second. Okay, so it's like a gear. The gears have those little notches on them, not like a sun. Maybe it's hooked to another gear here. And, as it spins, this is going to rotate 2 times every single second. Okay, so sometimes drawing a picture might help you visualize it. That's not the greatest. But let's see what else it says. X is time in seconds. Y is number of revolutions. Revolve, turn. What is the equation that models the number of revolutions over time? Then we're going to graph it. Now, let's look at this. Did it say anything about, it's already done 100 revolutions? We've only been told that it does 2 revolutions per second. X is the time in seconds. Y is the revolution. So let's go ahead and just use our equation up here. And this one is slightly different. It's an easier version of the other problems because there's no constant. Really, the only part of the information we give is going to be this part of the equation. Because we have the number of revolutions, right? Revolutions. And then we have 2 revolutions. X is the number of seconds. So 2 revolutions per second. We're going to go ahead and put it as 2x. So we know that's the revolutions. We know that it's going 2 revolutions per second. Now, once you have the equation, throw in an idea here. Get an idea on, is this right? Good, Jessica has it. Good. When I look at this, how about after 10 seconds? So what happens after 10 seconds? Whoops. Okay. So what we would do is we'd plug in, since X is time in seconds, we would just plug in 2 times 10. We would get 20 revolutions, right? Total. If you revolve, you turn twice, right? In 1 second. If you're going over 10 seconds, then you revolve 20 times. Okay. So this is our equation that now we just have to graph. And I look at that and I say, well, there's no B value. There is a B value. Whoops. Yeah, it's fine. There is a B value for this. What is my B value? Put in the chat. Nice, Cadence. Got it. Yeah. Good, Rocco. Good, Ahmed. Haley, good. All right. Axel, perfect. Perfect. So watch. Plus 0. There's a value there. It just has no value. It's 0. Okay. Anytime there's something missing here when you're trying to match it with this, right? It's about seeing this pattern. Okay, it's y equals m times an x plus some number out here. So I look here, y is equal to m times x plus, well, there's no number, but it's really going to be just plus 0. All right, Jade is here. Jade is here. All right, I think you just got booted out because I had you already signed in. Good. Okay, so look, first step, step 1. Plot your b. That's the y-intercept. The b, in this case, is 0. Watch. Here's my y-axis, here's my x. The first step is just to see where you're starting. This is the starting point, and then we're going to use our slope to find our next point, and then make our line. So number 2 is going to be, use m, slope, to find next point. Okay, so let's look. Our slope is 2. We know that a slope of 2 is 2 over 1, right? 88, 88 over 1. Okay, 7, 7 over 1. A whole number is always over 1 because a whole number, or a fraction, is a division problem here. 88 divided by 1 is 88. So we can look at that as 2 over 1. So it is rise over run. So if I have 2 as a rise, am I going up or down? Up. If I have 1 as a run, am I going left or right? I'm going towards the positives because these are both positive numbers. Positive is to the right, positive is up. Just like you read from left to right, these numbers go up as we go to the right. These numbers go up, right, as we go up and down. Down here is going to be negative. Down here is going to be, on this side, is going to be negatives. So just remember, you know all these little parts. You just have to put it all together. So let's start here. We're going to go rise of 2, 1, 2, a run of 1, right there. So I got my other point, and now I can make my line. Done. So this is part of what I need to see. This is part of what I need to see. The graph and the equation. Okay. Okay. Throw questions in the chat if you have them. How did that seem after you saw it? Thumbs up or sideways or down? How do you feel about that now? How do you feel? Let me know. It helps me and helps you. Yeah. Thanks for turning on. Okay. So good. Let's go ahead and just keep on going. We'll use the same method. So I'll keep these, these steps and everything here for us. But let's look at number 4. So number 4, let's just read it. A relationship between Celsius and degrees Fahrenheit is linear. To convert a temperature from degrees Celsius to Fahrenheit, multiply the temperature by a rate of 9/5 and add 32. What is the equation that models the conversion of degrees Celsius to degrees Fahrenheit? All right. So right away, when you look over it, first just read it, let it sink in. What the heck is it talking about? And then we want to go in and just put in some bullet points. Let's see. Okay, it's linear, so we're going to make a line. That's helpful. To convert a temperature from degrees Celsius to Fahrenheit, multiply the temperature by a rate of 9/5 and add 32. So look, to convert a temperature from Celsius to Fahrenheit, right? Multiply the temperature. So multiply the C here. Multiply the C by 9/5 and add 32. So let's look at this. Really what we're setting up is, I'm just going to write that. Multiply, it's almost like a part of this. Multiply C by 9/5, then add 32. Okay. This one's kind of a weird problem too. Nice, Jessica, you got it. All right, first step, because we know when we're making our equation, the key and number 1 step is, what is my B? Step 1, what is my B? What is my B? What is the constant that isn't going to change? What is the constant that isn't going to change? Good cadence. Good, good Amit. Anybody else? So we're looking at this right here. Good, good Matthew. Go ahead and put a plus sign right there. All right. So looking here, if we multiply C by 9/5, then we have to add 32. I know that my number that I have to add, and it's just a constant, is plus 32. Okay. And what they said was to go from Celsius to find, this is what our goal is. This is what we're looking for. That's our goal. To find the degrees Fahrenheit. Okay. All right. So if I'm looking at this, I know that I'm looking for F, and that's equal to taking our C value, whatever our C value degree is, and multiplying it by 9/5. So I know that's my slope. Whoops. Let's change that to be a C. If you wrote it like this, that's fine. It doesn't matter. It don't matter. Okay, I see a lot of people coming up with the final answer. That's great. Now, here's the thing. If you're like, well, how did you know? How did you know what goes here and what goes there? This is the only other piece of information other than the constant of 32. So first strategy is find the constant, find your B value, and then you'll be able to figure the other piece of information is likely going to be your slope. Okay, so now let's just go graph this real quick. There's some good questions about, well, how do I make 32? How do I make 32? Do I have to number this 1, 2, 3, 4, 5, 6 all the way to 32? I'll run out of room. Okay, you can number these as much however you want. Let's number this. Let's number these by 8. So if I did that, that's 8. That's 16, 24, 32. And just for consistency, I'll do it here too. It doesn't matter what the units are. You can decide that this would be 100, 200, 300, 400. You could do 1,000, 2,000, 3,000, 4,000, right? You can make it 2, 4, 6, 8, and so on. It doesn't matter how you label them. I say keep them the same, but you can even modify and have different scales on the different axes here. But we know, first step, we got to plot our B. We plot our B, and that's right here. Okay. Now, we need to get to our next position here, and it's going to be a little tricky with our units, but let's just try it. Okay, I'm going to number up a little bit more. This would be 40, 40, 48, 40, 48. It's not going to be perfect. If you did this on Desmos, you'd have room to not use these scaled values, but I hope that's still okay. Who made a huge graph? Who made a huge graph that took a whole page? Anybody? It's not wrong. It's thorough. You can just do this as a trick, okay? Let's keep it at this. So we're going to go from here. We're going to go up 9 because it's positive. We're going to go to the right 5 because that's positive too. So watch. From 32, I go up 9. I get to approximately 41. I get to 41. And then I go over 5. So I'm going to end up, if here's 8, 5 is a little past. I'd say that's approximately. I'm going to put this as a point. This is at 32 plus 9, so 41 for y up here. And then it goes over 5 for x. So that point is 541. And how do I know that? Because 541, if we go up, which is our y value, we go up 9, we get to 41. And then we had to run to the positive right 5. So up 9 over 5 gets us 5 for x, 41 for y. And the last step is always make your linear equation. All right. Okay. All right. Yeah. All right. Great. Downsized the graph units. Downsized it. Downsize. That's fine. There's a bunch of ways. We'll find a bunch of ways to show this a little clearer. Okay, but that is number 4. Unfortunately, with just reviewing homework, I have to just keep going. But I will take any questions. You could even unmute to ask it in real life. Why don't I just open this up as well? You guys can take a screenshot of this if you need it. Okay. All right, screenshot. You got 5 seconds to screenshot it. Oh, okay. Let me see 1 sec. 4 and 5 in the book. All right, 3, 4, 5. Okay. 3, 4. Wait, where did that come from? 6. Okay. All right. That's fine. That's fine, Natalie. I'm going to do 5 and 6 in the book or in the workbook, and then we will have a little break. Okay. Maybe I'll get to 7 too. 5, 6, 7. How about that in the workbook? And again, if we don't get through all of them, I'm recording these in other classes too. So I will post these and label them for what numbers are in each video. Okay. All right. Let's look at 5. Oh man, maybe this would be a quicker one. Let's see. A cab company charges an initial rate of $2. Okay, an initial rate of $2.50 for a ride. $2.50 for the ride. You're going to pay $2.50 if you get in the car, right? Plus 40 cents for each mile driven. That's the one that's the variable because the miles driven changes how much it costs. What is the equation that models the situation? So remember, we're always going to this equation. This is in the book, workbook, mx plus b. My constant is what I always want to find right off the bat. Constant. So if I look at my B, what is the constant that you're going to pay no matter what? Initial rate of $2.50 for a ride, any ride, plus 40 cents for each mile driven. Good. Okay. Good. Matthew, Natalie, got it. So watch. I'm going to input here the constant. You're going to pay $2.50, even if you decide I don't even want to go more than a block. Okay? Because that's the constant. That's the initial rate. Okay? Now, 40 cents for each mile. 40 cents for each mile. Okay? Now you may look at this. How does this, look at this right here. Read that. What does that say? It's not 0.4. How could you say that? How else could you say it? 0.4 or 4 what? 4 tenths. Right? This is 4 tenths. If you take 4 and divide it by 10, you get 0.4. So I'm just going to show this as like, we always look for the constant first. We knew it was $2.50, and then this is the rate. It's always going to go in the same place every single time. Good. All right, Matthew, perfect. So I'm going to just reduce this and graph it. I can reduce this by dividing that by 2 and that by 2. 2/5 is the same as 4 tenths. It's just reduced, 2.5. So now we're ready to graph it. Let's graph it over here. All right, so the key with these word problems is find the y-intercept first. What is the constant that you're going to pay or that always is included? And now we just have to graph our b value, our y-intercept. 1, 2.5. Okay. That always goes on the y-axis because it's the y-intercept. It's where it crosses, where the line is going to cross your y-axis in any direction. So once we have that, now that's our starting place. Our steps are going to be +2, that's going to be up. +5, that's going to be to the right. So all I need to do is from here, I need to go up 2, 1, 2. I need to go over 5. 1, 2, 3, 4, 5. Done. So this is y is equal to 2/5 x plus 2.5. All right, are they kind of coming a little bit easier now? They're getting a little bit easier to see the process? Okay. The key is the constant is going to be like our red flag. We got to go for that first. Plot that and then use the slope. That's going to be our rate, whatever it's given, to get to our next point, and then we just make our line. Okay, so this was our step. We went up, right? We went up 2. We went to the right. Let's see, positive 5. So always first step, first, y-intercept. Second, use your 2 slope to find next point. Okay. All right, let's see. Yeah, we'll do these. I have to keep going. Unless there's any questions coming up. Always in the chat while I'm even teaching, you could just throw in a question. All right. Let me see if I can just put it over here so you can still read it. All right, number 6. Matthew receives a base weekly pay of $300. So what does that mean? What does it mean to get a base pay of $300? That means that's what you're going to get after a week's work. You get a base pay of $300 plus a commission of $50 for each vacuum he sells. So the variable there is connected to these $50 for each vacuum because I could sell 10, I could sell 2, I could sell 1. And this is our base, so I'm saying that is our constant. So the $300 plus commission, that's really talking about $300 is going to be our constant. The commission is $50 per vacuum I sell. So here we go. Y is equal to, I know my constant was I'm definitely getting $300. And I'm getting, look, $50 per vacuum I sell. Again, the key, we only have 2 things to input. You start with this one, start with this first. The constant's going to be easier to recognize in the word problem. Then you're going to use the variable or the thing that could change based on the number you sell. That's always going to be your M value. And now this is going to be a pretty big graph here. So let me just abridge it a little bit. Let's see. Let's do them by hundreds. 100, 200, 300, 400, 100, 200, so on. All right. So first step, graph your y-intercept. First step, 300, right there. Y-intercept, where it crosses the y-axis. Now we have to go up 50, and I look here, and it's 50 over 1. So this is actually going to be a really weird graph because we have too small of units here. If I go up 50, I'm halfway up, and then I'm really just going over a little bit. So this is going to be a graph that's like this. Even steeper than that. That would be hard to graph by hand. It is hard to graph by hand. If I see this, and this is your effort, and I see that you made the appropriate slope, you have the right y-intercept, that's what I want to see. That's it. Thumbs up, getting easier. Thumbs up, getting easier. Sideways, still tricky. Thumbs down, not getting it. All right. Still in the middle? No worries. If you are still in the middle, can you verbalize it? Most teachers won't even ask this. They'll just move on. Can you verbalize the part that is the trickiest? The part that is the trickiest. Is it finding the equation? Is it, figuring out what goes in as the constant or not? Is it graphing it? Is it being familiar with the graphing? Is it finding the point to start and then using the slope? So there's different parts here. So in the chat, let me know. It's the actual graphing. Okay. So how about we do these? We've been having hard numbers, tricky numbers this whole time. Let's do this one. 3 halves x plus 100. So it seems like we're mostly okay. Not 100. Let's do 10. We're mostly okay with finding this, knowing that's the constant and that's the slope. Okay. There's only 2 things to do. There's only 2 things. First, you got to have a starting place. And then a slope is just steps. We use the steps to get to our next point. Starting point, slope to use steps to get to your next point. Make your line. That's it. So let's look. If we have this here, Y-intercept is 10, so I need to go to my y-axis. It's literally where the line is going to cross your y-axis. It's where the line is going to cross your y-axis. So here at plus 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. Magic. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here is my y-intercept at y is equal to 10. Okay. First step. Next step. This slope, let's pull it out for a second. 3/2 is my slope. I know this is the rise over the run. Maybe this is a key problem that's going to help you put it all together. The slope is the rise over the run, so we have plus 3. That means we're going up. You can have a negative rise. That means it's going down. But since it's positive, we know we're going to go up from this point. Then a run of positive 2 is going to be towards the right, towards the positives. So we're going up positive. We're going to the right positive. So let's do it. We'll go up 3. 1, 2, 3. Over positive 2. 1, 2. There's our next point. You see, we made a step. The slope is just a step. It's how much you rise and then how much you run. Sometimes it goes up and to the left if it's a negative run. Sometimes it goes down and to the right if it's a negative rise, right? So since it's plus 3, we know we go up. Since it's plus 2, we know we go to the right. So plus 3, plus 2, that gets us to our next point. That's all we need in order to graph. Okay. Maybe we'll get that long break. Not sure. Good refresher. That's what I'm here for. So when you ask for it and you get it, right? Yeah, if it makes more sense, it's helpful, right? You got to ask. I'll never be mad for you asking. I get actually frustrated if nobody asks. I want to know. So thank you for letting me know and showing that. And how about this? For number 7, I'm just going to show you it. And you know what? This is actually a little bit harder because of the numbers involved. Okay. So number 7, I'm going to pause this right now, and I will do number 7 next class. Okay, I'm going to actually stop this. And let's see, right now it is 10:07.